In this example, it looks like we have ourselves a nice matrix equation. We have 4 times D, which is a matrix, and to that we're going to add this 2 by 3 matrix, and at the end we're going to have this 2 by 3 matrix. So that means that the dimensions of D must be 2 by 3 in order to ensure that this works out. So the first thing to do, because we're trying to isolate this D on one side of the equation all by itself, and so the first thing we can do is go ahead and subtract this 2 by 3 matrix from both sides. And we'll just go ahead and write all these entries right here. So we know ultimately this will just cancel. That's the goal. And then we'll have the 2, -7, 4, -6, 3, and 0 here. So what I'll be left with on the left side is 4 times D, which D again is that matrix that we're solving for. And here on the right side I have this 2 by 3, and I'm going to subtract this 2 by 3. And again they have the same dimensions, so all I'm going to be doing is subtracting their corresponding entries. So first 6 minus 2 will be 4, and then we have -3 minus a -7. So when we're subtracting a negative, really we're adding. So -3 plus 7, that'll be 4. And then we have -4 minus 4, and that'll give us a -8. And then we have a 2 minus a -6. And again, the subtraction of a negative makes addition, so 2 plus 6 is +8. -9 minus 3 will be a -12. And 8 minus 0, of course, that's just going to be a nice 8. Okay, so what we can do now is multiply both sides by 1/4. So that will get this D isolated all by itself. And this 1/4 on the right side will function as a scalar multiplication here. So I'm going to take this 1/4 and essentially just distribute it to every single term in this 2 by 3 matrix. So this scalar product then will become, well, 4 divided by 4 is 1, 4 divided by 4 is 1, -8 divided by 4 is -2, 8 divided by 4 is +2, -12 divided by 4 is -3, and finally 8 divided by 4 is 2. So my solution here, this 2 by 3 matrix, which is going to be my matrix D, is going to be here, and this is the matrix that if I slipped it right in there, I could multiply everything by 4 and add this matrix, and I would indeed get this 2 by 3 matrix here at the end.